So this is my predicted paper for paper 3 foundation on the 14th of June 2023. It's calculator. I've already got the higher one up. You can find that on YouTube already, but this is foundation. Let's have a go. Here are the topics that I think are likely to appear. Question number 1, write 3/10 as a percentage. So to go from a fraction to a percentage is going to be out of 100. At the minute we have 3/10, which is only out of 10. To make it out of 100, that's okay. We just need to times the bottom by 10. And whatever we do to the bottom, we need to do the same to the top to keep it equivalent. So that's going to be 30 out of 100, and therefore that is 30%. Question number 2, write down the value of the 4 in the number 542.3. Well, the 4 is in the tens column. So it's 4 tens, and you can either write 4 tens or you can write 40, but you can't just write tens. Yes, it's in the tens column, but that isn't the value of the 4. The value of the 4 is 40. Write down a square number that is also an odd number. So your square numbers are 1, 4, 9, 16, 25, and so on. It's 1 times 1, 2 times 2, 3 times 3, 4 times 4, 5 times 5, 6 times 6 would be 36, and so on. So we need one of those that's also odd, and you could pick 1, you could pick 9, you could pick 25. Odd are numbers not in the 2 times table. So the 2 times table, your even numbers are 2, 4, 6, 8, 10, so on. Your odd numbers are all the numbers in between those. So 1, 3, 5, 7, 9, etc. Now the only other thing they might ask you about, if they're asking you about types of numbers, is prime numbers. And remember that prime numbers are numbers that are only divisible by themselves and 1. So that's 2, 3, 5, 7, 11. They're only in their own times table and the 1 times table. Really commonly, they've asked you a lot in previous years about a prime number between 20 and 30. So just remember that 23 and 29, they're your prime numbers in the 20s. But this question, sorry, I've got a bit off track there. Write down a square number that's also an odd number. I'm just going to go for 9. 9 is 3 times 3, so it's a square number, and it's also an odd number because it isn't in the 2 times table, but you could have had lots there. Question number 4, work out an eighth of 720. So when we do a fraction of a number, you can just type in your calculator 1/8 times 720, and typing that in your calculator will get you the right answer, but it's also good to understand what we're doing. So we're dividing into 8 parts, and then we just want one of them. So divide by the bottom, times by the top. 720 divided by 8 is 90, and then we're just timesing that by the top number, which happens to be a 1, so we're keeping it the same, and that's just 90. So if you're doing a fraction of a number, divide by the bottom, times by the top. Okay, question number 5, find the value of 6 to the power of 5. So this means 6 times 6 times 6 times 6 times 6. 6 to the power of 5 is multiplying that 6 by itself. 6 times 6 times 6 times 6 times 6, 6 to the power of 5. So in my calculator, you can either type it like that, or you can use the power button. So if I type 6, and then there's a button with X and a little square, and that square is just coloured in white, and we can press that button and choose whatever power we like. But if you do 6 times 6 times 6 times 6 times 6, that's absolutely fine. 7,776 is your answer to that one. Question number 6, work out the value of P when R is 5 and Q is minus 4. So if R is 5, that's going in there. If Q is minus 4, that's going there. So we're changing the letter to be that number that they've given us. So P is 7 lots of 5, add 3 lots of minus 4, because remember that 7R means 7 lots of R, and 3Q means 3 lots of Q, sorry. So we're timesing those together. P equals 35, add minus 12, and 35, the plus minus, that's the same as a takeaway. So we're doing 35, take away 12, and that is 23. Question number 7, Margaret's thinking of a number. She says, my number is odd. Okay, so we know that odd numbers are 1, 3, 5, 7, 9, 11, etc. It is a factor of 36 and a multiple of 3. So factors of 36 are numbers that fit into 36 an exact number of times. So factors of 36 would be 1 and 36, 2 and 18, 3 and 12, 4 and 9 and 6. I've not written that very clearly, but there you go. They're all your factors of 36. They all go into 36 an exact number of times. The multiples of 3 have to be numbers in the 3 times table. So 3, 6, 9, 12, 15, 18, 21, and so on. Now, Margaret was thinking of a number that is odd, a factor of 36 and a multiple of 3. So let's look. We've got 3, that's both. We've got 9, that's both. We've got 12, that's both. We've got 18, that's in both of those lists there. Oh, 6 as well. But they've also got to be odd. And 6 is even, 12 is even, and 18 is even. So the only odd ones there are 3 and 9. And they're your two answers. Odd, factors of 36, and multiples of 3. Question number 8. Here are the marks 20 students got on a French test. Show this information in a stem and leaf diagram. Okay, so for a stem and leaf, I like to do a draft one first. So up here, I'm not going to do it on the proper one just yet. I'm just going to do one up here, which is going to be not in order. And that's going to help me just to get all the data into the table, and then I can worry about ordering it afterwards, because I find that when students try and order it at the same time as do it, it tends to go wrong, you miss one out or things like that. So let's just go through in order. Now we've got numbers in the 60s, the 70s, the 80s and the 90s. So this stem here is your tens, or appropriate, whatever the value is, and then we've got all the other numbers to put on the other side. So 76 is going to go in the 7 row because it's in the 70s, and we just put a 6. And I'm just like to put a comma between each one, but you don't have to, as long as it's nice and clear that they're separate. And then 82 goes here, 84, 69, 80, 64, 70, 81, 75, 91, 87, I feel like a bingo caller, 67, 80, 70, 94, 76, 81, 69, 71 and 77. So that's all my data in, and now I just need to worry about putting each row in order. So now I'm going to transfer it onto the proper one. Still the tens are in the 60s, 70s, 80s, 90s. Now for this first lot of numbers, these need to go in order. So I'm going to put 4, 7, 9, 9. Then for the second row, I need to put them in order. So I'm going to start 0, 0, 1, 5, 6, 6, 7. And then for the next row, again, I need to put them in order. So 0, 0, 1, 1, 2, 4 and 7. And then the 1 and the 4 on the 90s row. That's just stayed the same. I'm now just going to put a neat cross through this to show the examiner that's not my final answer, this is. And then I'm just going to count how many values. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And that's how many we had, how many pieces of data we had in the beginning. So I know that I've done that correctly and I've got all of my pieces of data in. Always check that, because that's the first thing an examiner will look for, is if you've managed to get them all in and you've got 20 pieces of data there. There's one last thing we need to do to get full marks here, and that is a key. So I'm just going to do a little box. I'm going to say key, and I'm going to use the first number as my example, but it really doesn't matter. It doesn't even need to be a piece of data that's in the table. You're going to put 6 line 4 equals 64 marks. No, yeah, marks. That's what it stands for. That's what it means. Sometimes if these were all decimal numbers like 9.1, you wouldn't bother putting the point in the table. You'd just use the key to do that. So you'd put like 91 in the table just as you have here, and then in the key you'd say 9 line 1 means 9.1. So the key just means that if it's a bit tricky or if someone doesn't know how to read it, that's just going to help them out. One of the students is going to be chosen at random. The pass mark in the French test is 71. Omar writes, the probability that a student fails is a quarter. Omar is wrong, explain why. So let's just look. There's 1, 2, 3, 4, 5, 6 students there that failed because they got less than 71 marks. So 1, 2, 3, 4, 5, 6 out of 20. That's how many people there are altogether. Now, is that a quarter? No, it's not. So 6 over 20 simplifies to 3 over 10, which is 30%. And a quarter is 25%. So Omar is wrong, because for it to be a quarter, it would need to be 5 out of 20. And actually 6 people passed. So a quarter would be 5 people failing but 6 students failed the test. Good, and we can see that there. Wonderful. Question number 9. Andy went on holiday to Canada. His flights cost a total of £1,500. Andy stayed for 14 nights. His hotel room cost $196 per night. Andy used Wi-Fi for 12 days, and the Wi-Fi cost $5 per day. The exchange rate was $1.90 to a pound. Work out the total cost of the flights, the hotel room, and the Wi-Fi. Give your answer in pounds. Okay, this bit's in pounds, so that's okay. But we now need to work out the cost of the hotel and the cost of the Wi-Fi in pounds so we can add it all together. I can't add it together at the minute because it's in different units. So if $1.90 equals £1, then to go from pounds to dollars, we are timesing by 1.9. And to go from dollars back to pounds, we're dividing by 1.9. I always find it helpful to do that diagram for currency conversion. So Andy stayed for 14 nights, and the hotel room is 196 per night. So I'm going to start by doing 196 times 14 to get the total cost of the hotel. And that is $2,744. Now to get that into pounds, we know we need to divide by 1.9. So I'm going to take that answer, divide it by 1.9, and that is £1,444 and 21 pence. I'm rounding it to 2 decimal places because it's money. Now for the Wi-Fi, 12 days he used the Wi-Fi at $5 per day. So 5 times 12 is $60. And again, we need to get that into pounds. So I'm going to divide by 1.9. And that is £31.58 because it's 31.578. So that would round up. So 31.58 is my answer for that bit. And now I'm going to add together the flights, add the hotel, add the Wi-Fi, add it all together and get the total cost. So 1,500, add £1,444 and 21 pence, add £31.58, and that is £2,975 and 79 pence. And that's our answer. If there were fewer dollars to a pound, what effect would this have on the total cost in pounds of Andy's holiday? Okay, so I find this quite difficult to visualise without doing an example. So if there were fewer dollars to the pound, so let's say a pound, before a pound was $1.90. So they're saying, what if it was only $1 that you got? Then what would happen to the cost? So we're saying if we get less dollars for our pound, what effect does this have? Well, what would have happened here? Instead of it being $60 wouldn't have gone to £30, it would have stayed at £60-ish if it wasn't dividing by as much. So we would have been dividing by a smaller number, and dividing by a smaller number would have kept that price higher. So it would have been more expensive. So it would have cost more. But if it doesn't make sense, do what I do. Just think up an example and then do it and think, okay, has that gone up or has that gone down? Question number 10, we have a pictogram. The pictogram shows information about the number of video games sold in a shop. We've got Monday, Tuesday, Wednesday, Thursday, Friday. How many video games were sold on Monday? So we can see from the key here that 4 squares represents 8 video games. So if I do 8 divided by 4, it's going to be 2, 2, 2, and 2. So on Monday, I can see that I've got 8 here and 8 here. So 8 add 8, that's going to be 16 video games sold on Monday. On Thursday and Friday, a total of 32 video games were sold in the shop. A quarter of these 32 video games were sold in the shop on Thursday. Complete the pictogram for Thursday and Friday. So these two need to make 32 and a quarter of 32. Now remember, you can do a quarter times 32 in your calculator, or you can divide by the bottom and times by the top. So 32 divided by 4 is 8. So we then know that 8 of them were sold on Thursday, and we know that that looks like this. And the rest of them were sold on Friday. So a quarter of 32 is 8. 32 take away 8 is 24. So on Friday, we need to draw 8, 16, 24. And that looks like that. Wonderful. All done. 3 marks. Ishmael asked 30 students at college to tell him the sport they each like best, from cricket or tennis or swimming. 11 of the 20 female students, okay, so now I know immediately, I'm going to fill this out as we go down, that the number of female students is 20 and 11 of them said swimming. So swimming here is going to be 11. 2 of the male students said tennis. So male student saying tennis was 2. And we know that there are 10 male students because 10 add 20 makes 30. 5 students said cricket, so it's not telling me if they're male or female, just 5 students said cricket, so that's going to go in the total there. And now we just need to make sure that everything adds up. It also says the number of male students who said cricket was the same as the number of male students who said swimming, so this number and this number need to be the same. Now we know that there were 10 males altogether. And if 2 of them are here, there are 8 left. So that means 4 of them must have been playing cricket or wanted to play cricket, and 4 of them wanted to go swimming. So they had to be the same, and it had to add up to make 10, so those are the only answers there. Now 4 add 11 is 15. 5 and 15 makes 20, so there must be 10 here. And 2 and 8 makes 10. And then we just need to make sure that these 3 numbers add to make 20. So I've got 8 and 11, which makes 19. So I've just got 1 left to make that 20. And 4 add 1, we can see also makes 5. So I'm happy with that. That's all correct. And we've completed it. There's no probability here. Sometimes they give you a probability section to this question. So they'll say, I'm going to pick one of the females at random. What's the probability they chose tennis? So that would be 8 out of 20, for example. But they haven't here, so that's okay. Question number 12, expand and simplify. So we're going to multiply out these brackets by doing the first times the first times the second times the first, and the second times the second. So first, x times x, and that's x squared. Then we're doing x times minus 9, and that's minus 9x. Then we're doing 5 times the x, which is 5x. And then we're doing 5 times minus 9, which is minus 45. Collecting together your like terms, minus 9 add 5. Think about a number line. If you're down at minus 9 and you add 5, you're going to come up towards 0, and you're going to get up to minus 4. So x squared minus 4x minus 45 is your final answer for that one. Okay, question number 13. Here is a rectangle. The 6-sided shape below is made from 2 of these rectangles. Work out the perimeter of this 6-sided shape. So we know that this is 4, this is 6, this is 4, this is 6, this is 4, this is 4, and this is 6. Now perimeter is the distance all the way around the outside. So I want this side, this side, this side, this side, this side, and this side. And I remember marking this question actually on a previous year, and lots of students included this value here, but because that was not on the outside of the shape, you didn't need it. But you did need to work out this little bit here. Now this little part here is actually the difference between 6, which we know is that height there, and 4, which we know is this width here. So this part here is 2. So I'm going to add together 6, 4, 2, 6, 4, 6, and 4. Adding all of that together. Six and 4 makes 10, so I'm just going to quickly go like this, and that is 32. 10, 10, and 10. So yeah, 32, quickest way to add them up. And that's your answer. Question number 14. In a shop, a TV has a price of £500. The shop has a sale. On Monday, the normal price of the TV is reduced by 1/10 to give the sale price. On Tuesday, the sale price of the TV is reduced by 20%. Chris wants to buy the TV. He has £400 to spend on the TV. Does Chris have enough money to buy the TV on Tuesday? You must show how you get your answer. So we're going to start with £500, and we're taking off 1/10. It's reduced by 1/10. So let's find 1/10 of that number, and remember we're dividing by the bottom and then timesing by the top. So 500 divided by 10 is 50. 50 times 1 is 50. So that's £50. So we're taking 50 off for Monday. So Monday we need to do £500, take away 50. So after Monday it's £450. Now on Tuesday we need to reduce the sale price by 20%. So on Tuesday we're going to take that £450 and we're going to do 20% of 450. Now 10% of a number we would divide by 10. So 10%, Let's divide this by 10, that's 45. So 20% is 2 of those, and that's 90. So for Tuesday, we need to now take off £90, and that brings it down to 360. So Chris has got £400. Does he have enough? Yes, he does. So we need to answer their question. Whenever they ask you a question, make sure you're answering it. Does Chris have enough money to buy the TV on Tuesday? Yes, Chris has enough money. We've got 360 there, so they can see that we're okay with that. Wonderful. Question number 15. The diagram shows a square ABDE and an equilateral triangle BCD. Work out the size of angle EBC. So angle EBC is the angle that is made when you draw along E to B to C. So it's that angle there that we're after here. We want this bit, but we also want this bit. Now, because we're told this is an equilateral triangle, I know that all 3 sides here are the same length. Angles in a triangle add up to 180. And if all 3 sides of that triangle are the same, then all 3 angles would be the same. So to get all the angles inside this triangle, I'm going to do 180 divided by 3, which is 60. So that means this is 60 degrees, this is 60 degrees, and this part here is 60 degrees. Now, ABED is a square. So we know that in each of the corners, we have a right angle. And because this line is cutting it diagonally, it's 45 degrees on each half because I've taken a right angle, which is 90 degrees, and divided it equally in 2. So that means the bit that we're looking for, which is this section here, is just 45 degrees, add 60 degrees, and that's 105 degrees. Question number 16, make x the subject of the formula. So at the minute, y is the subject of the formula because the y is on its own, and then the equals, and then everything else is on the other side of the equation. So to make x the subject of the formula, we need to get the x on its own. Now this is a bit like solving equations. So the way I like to do this is to put a dotted line where the equals is. And remember that with equations, what we do to one side, we need to do to the other. So if I want to get the x on its own, remember this means 2 lots of x, add 4. So the first thing we're going to do is take away that 4. And if we take away 4 from the right-hand side, we've also got to take away 4 from the left-hand side. Now, y and 4 are not like terms. So I'm going to write y take away 4. I can't make them one term because they're not like terms. And that equals 2x. Now I've got 2 lots of x, but I don't want 2 lots of x. I just want x on its own to be the subject of the formula. So we're going to divide this side by 2 to get that x on its own. But if we've divided the right-hand side of the equation by 2, I also need to divide this side by 2. Now we need to divide it all by 2, so I'm going to put y minus 4 all divided by 2. And that's your final answer. I do just like to flip it round for the answer line though. So x equals y minus 4 all divided by 2. But you wouldn't lose marks if you didn't. If you left it like that, that's absolutely fine as well. Question number 17. Hannah is planning a day trip for 195 students. She asks a sample of 30 students where they want to go. Each student chooses one place. The table shows information about her results. Work out how many of the 195 students you think will want to go to the theme park. So Hannah's asked 30 people, but actually there's 195 students that are involved in the school or whatever that are going on the trip. So actually we need to make this how many times bigger. Now I think the easiest way to do this question, there's lots of different ways to do the question, but I think if you do 195 divided by 30, we're going to find out how many times bigger we need to multiply her survey. So 195 divided by 30 in my calculator is 6.5. So if she multiplies her results by 6.5, that would give her a good estimate of it being out of 195 instead. Now we haven't got to work them all out. The only one we've got to work out is the theme park. So if I times that by 6.5, that's going to get me 65 students. And so that's how many we actually think would want to go to the theme park. So that's one way of doing it. Another way of doing it would be to say that she asked 30 students, 10 out of 30 wanted to go to the theme park. And if you times that by 195, so this fraction of 195, you also get 65. So lots of different ways to do it, but 65 was your answer there. State any assumption you made and explain how this might have affected your answer. So with samples, If you only ask a few students and you scale it up to make predictions about a bigger sample size or a bigger group of students, a population, you have to hope that the people you asked are a good representation of all the students. What I mean by that is that she didn't go and ask 30 year 7s and then the 195 going on the trip are actually all year 11s. Or maybe she asked primary school students when it was a secondary school trip, or she only asked year 7s when it's year 7, 8, 9, 10 and 11 going, things like that. So there are lots of different things that can affect your survey, but you want to make sure that if you're taking students from year 7, 8, 9, 10 and 11, that you ask a selection of students from year 7, 8, 9, 10 or 11. I think my handwriting's getting worse, you know. There we go. Question number 18. A is simplify n cubed times n to the power of 5. Now n cubed is n times n times n, and we're timesing that by n to the power of 5, which is n times n times n times n times n. So we know that altogether that's going to be n to the power of 8. When we multiply, we add the powers. For part B, we're dividing. So when we divide, we take away the powers. If I've got c cubed divided by c squared, I'm just doing 3 take away 2, which is c to the power of 1, but we don't bother writing the power of 1, we'll just keep it like that. And then d to the power of 4 divided by d. Now remember that d is the same as to the power of 1, and 4 take away 1 is 3. So that's going to be d to the power of 3 for 2 marks. Question number 2. Last year, Jo paid £245 for her car insurance. This year, she has to pay £883 for her car insurance. Work out the percentage increase of the cost of her car insurance. So percentage increase or percentage decrease or profit is change over original times by 100. So the change is just how much it's changed by. The original is what it was first. In this case, that's 245. And then we're just going to times it by 100 to get it as a percentage. So the change is 883 minus 245. And it's out of the original, which is 245, times by 100. So percentage increase, percentage decrease, or profit, you're going to do the same formula, and it is that change, 883 minus 245 over 245, times by 100. So change over original times by 100, and that is 260.4%. So it's a 260.4% profit. Now that makes sense, because if it was an 100% increase, it would have gone from 245 and it would have doubled and been 490. So that would have been an 100% increase. And actually, if we add on another 245, that would have been another 100% increase. So that's not a crazy answer. It seems a little bit crazy, but it's okay. Question number 3. Complete the table of values for y equals x squared, add x minus 4. Now, if this was a non-calculator paper, I would be telling you to do this very differently. But given that this is a calculator paper, paper 3, I'm going to say do it one of two ways. The first way is to use brackets. So in your calculator, you are going to type this. But every time you see an x, you're going to use brackets. So bracket, bracket squared, add bracket, bracket, minus 4. So we're just rewriting this, but with brackets every time there's an x. Now all you need to do now is go back to those brackets and put minus 3 in both of them. Get your answer and then click the left arrow, go back to both of those brackets and change it to be a 0 in both of the brackets. And then left with your arrow on your calculator, go back, change them both to be 2s. And then go back and change them both to be 3s. And that will give you the answer for each. The other way to do it is to use the table function on your calculator. So if you click menu, and then it's 3 on mine, it might be slightly different on yours, but it will say table, f of x comes up. Now you're going to type x squared, add x minus 4. On my calculator, to get x, it's alpha, and then the right-hand bracket. So x squared, add, and then I'm going to do that alpha bracket again to get another x, take away 4. Hit equals. Mine says g of x, yours might not. Your calculator might just say f of x, that's fine. Hit equals again if it does, because I'm not interested in that. And it'll ask you for the start. Now the start is wherever your table is starting. In this case, minus 3. Hit equals. And then you need to say where it's ending, which in this case is 3. Hit equals. And then it'll ask you for the step. Now the step is just saying what is it going up in, and we're going up in 1s, and it will probably be 1, so let's just hit equals again, and now it'll give you the whole table, and we can see that minus 3 requires a 2, Minus 2 is a minus 2, that's fine, we've got those already. Going down, scroll down using your down arrow. 0 is minus 4, 1 is minus 2, 2 is 2, and 3 is 8. So either way, whichever way you're more comfortable with. Now I will just say, once you're done with the table, to get rid of it, just press menu and go back to 1. Menu 1 to get back to where you started. If you forget how to get back, just press Shift 9 3 equals AC. That will always reset your calculator and take you back to the main screen. There we go. Now each of those is a coordinate. So we're now just going to plot those coordinates. Minus 3, 2. Right, now before I start plotting, let's look at this very carefully. I've got 10 squares making 5. So this is 1, 2, 3, 4, 5. So it's 2 squares that make 1. So just be really careful when you're plotting anything on a graph. So we're minus 3, 2, which means we're going to here. Minus 2, which will be 4 squares down, so that's there. Minus 1, minus 4 is going to be there. 0 minus 4 is there. 1 minus 2 is there. And 2, 2. And 3, 8. You're just going to join that up with a nice smooth curve. Oh, if I can. Don't like that. Just a little bit, there you go. So make sure that when you're drawing a quadratic, if you've got 2 values at the bottom, that you want to dip slightly below them like that. Okay, nice, should be a nice smooth curve, but you shouldn't have a flat bottom like that. Should dip slightly below and come back up. There we go, so that's a quadratic drawn on the graph. And it then says, use your graph to estimate a solution to when that quadratic equals 0. So they're essentially asking us for the roots. They're saying, when does it equal 0, which is when it crosses the x-axis. If they asked you when it equaled 5, you'd need to draw a line going across at 5. If they asked you when it equaled minus 2, you'd draw a line going across at minus 2 and just look at where it crossed that line. But here they've just said, when does it equal 0? So we're looking at this coordinate here and this coordinate here. So my answers for this are going to be minus 2.7 and 1.5. Those are the 2 places where my quadratic equals 0. Question number 4. The table gives information about the times taken in seconds by 18 students to run a race. Work out an estimate for the mean time. Give your answer correct to 3 significant figures. So the mean from a frequency table, we know that one student here ran the race between 5 and 10 seconds, but we've got no idea if it took her or him 6 seconds or 10 seconds. We just don't know. But we're always going to have a sensible guess and go in the middle of the category. So let's just say 7.5. For the next students, we're going to say 12.5, then we're going to say 17.5, and then we're going to say 22.5. So that's in the middle of each of the categories. We then say one of those, 2 students each going 12.5 seconds, 7 students each doing 17.5, and 8 students doing 22.5. We times across, we add all of that together. So one lot of 7.5 is just 7.5, 12.5 times 2 is 25, 17.5 times 7 is 122.5, and 22.5 times 8 is 180. Adding all of that together, 122.5, add 25, add 7.5 is 335. Now, the most common mistake I see then, if they asked you the total, that would be your answer. But the most common mistake I see now when you're asked for the mean is people end up dividing by 4 because there's 4 categories. But there weren't 4 students. We were told in the question, and we could also work it out here by adding this column up, that there were 18 students. So 335 divided by 18 is going to get us our answer for the mean. And they want that answer to 3 significant figures. My calculator gives me 18.61 recurring. So to 3 significant figures, it's going to be 18.6. Just going to pop that down here on the answer line, 18.6 for 3 marks. Question number 5. Write 37 centimetres cubed in millimetres cubed. 1 centimetre is equal to 10 millimetres. So normally, if I'm going from centimetres to millimetres, I would times by 10. But I'm not going from centimetres to millimetres, I'm doing centimetres cubed to millimetres cubed, in which case I need to times by 10 cubed, which means times by 10, times by 10, times by 10. So it's not going to be 37, we need to times by 10, times by 10, times by 10. So the answer is 37,000. Question number 6, Nima was driving to a hotel. He looked at his sat-nav at 1:30 and it said the time is 1:30, the distance to your destination is 65 miles. Nima arrived at the hotel at 2:48. Work out the average speed of the car from 1:30 to 2:48. So first we need to work out how long that's been. Let's draw our triangle as well. Speed, distance, time. So to be able to work out the speed, we need to do distance divided by time. We know that the distance is 65 miles, but we don't know the time. So the time is from 1:30 or 13:30 to 2:48. Now that is 1 hour would get us to 2:30 and then another 18 minutes. That's how I work it out in my head anyway. 1 hour and 18 minutes. So I've got to now type that in my calculator. Now a lot of you would like to change that and make it 78 minutes and then you'd have to put it back into hours at the end. I really like for this method, because I want to do distance divided by time, I want to do 65 divided by an hour and 18. Now you can't type 1.18 in your calculator, that is not an hour and 18, but you can use the mixed fraction number. So you can put 1 hour and 18 out of 60. Now, if you're going to type that in, you have to use the mixed number fraction. You can't just type it in next to a number and a fraction. So you need to press Shift and the fraction button, and that will enable you to type that in as it is. So 65 divided by, and then press Shift fraction, and that is 1 and 18 out of 60. And that gets you straight away to the answer of 50 miles an hour. Of course, you can do 65 divided by 78, because it's 78 minutes. And 65 divided by 78 is 0.83 recurring. But then because that was in miles per minute, you then just need to times it by 60 to get it back into miles per hour, and that would be 50. So nothing wrong with doing it that way whatsoever. I just think this is slightly quicker, but either way it's going to get you the correct answer, so do whichever way you feel comfortable with. Question number 7, and we've got standard form. Write 1.63 times 10 to the power of minus 3 as an ordinary number. So timesing by 10 to the power of minus 3 is the same as dividing by 10, dividing by 10, dividing by 10. So 1.63, if we divide that by 10, we're going to get 0.163. Divide it by 10 again, we're going to get 0.0163. So this is going to end up being 0.00163. For part B, to write this number in standard form, it needs to be a number between 1 and 10 times 10 to the power of something. So this is going to be 4.38. Now, obviously it's the numbers that are moving, not the decimal point, but it's way easier for us to move the decimal point. So let's just say the decimal point is here at the minute, and we want it to be here. So that is 1, 2, 3, 4, 5 jumps. So it's 4.38 times 10 to the power of 5. Also good to remember that a million is times 10 to the power of 6. So if it's in the 100,000s, that's going to be times 10 to the power of 5. And then for part C, work out 4 times 10 to the power of 3 times 6 times 10 to the power of minus 5. Now you have a calculator. This question I think was taken from a non-calculator paper, but you've got a calculator, so you might as well just use it. And I would type it in exactly as you see it there. And that gives me 0.24 in my calculator, but I do now need to put that back into standard form. So that's going to be 2.4 times 10 to the power of minus 1. Question number 8. The diagram shows a regular pentagon and a parallelogram. Work out the size of the angle marked X. You must show all your working. So when we have a triangle, we know that the angles in a triangle add up to 180 degrees. For a quadrilateral or four-sided shape, we know it adds up to 360 degrees. And every time you add a side, you add another 180 degrees. So a pentagon is 540. A hexagon would be 720. Now the formula is the number of sides take away 2 times by 180, but I just know 180 bigger than 360 is 540, so for this question I'm happy to just say a pentagon, a 5-sided shape, adds up to 540 degrees. And because it's regular, we know that all of the angles inside the pentagon are the same. So I'm going to do 540 divided by 5 to find out how big each of these angles are around the outside, including this one here. So 540 divided by 5. How many 5s go into 5? That fits in once. How many 5s go into 4? It fits in 0 times, remainder 4. And how many 5s go into 40? That is 8. So I've got 108 degrees on each of these angles, including this one for both of them. Okay, so that's step 1. Now for step 2, we've got here a parallelogram. Inside a parallelogram, because you've got co-interior angles, you've got 117 degrees here, but you know that these two would add together to make 180. So 180 take away 117 is 63. So I then know that this angle here is 63 degrees. Out of interest, this one would also be 117 and this one would also be 63, but we don't need those two. So now we can just work out that the angle marked X here is just 108 take away 63. So 108 take away 63. 8 take 3 is 5, and 10 take 6 is 4. So we're left with 45 degrees, and that's our answer for angle X. Okay, question number 25. Joe is going to buy 15 rolls of wallpaper. Here is some information about the cost of rolls of wallpaper from each of 2 shops. We've got Chic Decor and we've got Style Papers. Joe wants to buy the 15 rolls of wallpaper as cheaply as possible. Should Joe buy the wallpaper from Chic Decor or from Style Papers? So for these questions, I like to split them up. Chic Decor there, Style Papers there. And for Chic Decor, 3 rolls costs us for £36. So 3 rolls equals £36, but we want 15 rolls. And so if we're timesing that by 5, we also need to times the cost by 5, and 36 times 5 is £180. So that's it for Chic Decor. Now for Style Papers, we buy a pack of 5 rolls for £70, but they've got a discount on at the minute of 12% off. So I want to find out what 12% is and take it off. So you can either do that before or after. So if there's a 5 pack of rolls and we want 15 rolls, so 5 rolls is £70, and then 15 rolls we're going to times by 3, so also times that by 3, and that is £210, but we need to take 12% off. So 12% of £210. Now the easiest way to do that in your calculator is to say, well, 12% as a decimal is 0.12, of we just write times, and then 210 in our calculator. So if you want to work out a percentage, you can just type it as a decimal in your calculator. 0.12 times 210 is £25.20, so that's our discount. So £25.20 is how much we need to take off. So 210, take away that answer, and that is £184.80. So that's the price at Style Papers. And then we just need to write a conclusion. They've asked us a question. They've said, should Joe buy the wallpaper from Chic Decor or Style Papers? So we're going to say Joe should buy from Chic Decor. That was the cheaper. There we go. And we've got the 2 answers there. Question number 26. ABC is a right-angled triangle. A to C is 14 centimetres. We've got a right angle here. The size of angle B to the size of angle A is in the ratio 3 to 2. So I need to know how many degrees there are in total so I know how to share it. When I share into a ratio, I like to do my little dotted lines, and we're sharing in the ratio 3 parts to 2 parts. So we need 5 little lines altogether, 5 parts that we're sharing those angles or those degrees into. So we've got 90 degrees here, and we know that in a triangle, the angles add up to 180. So if I do 180, take away the right angle that we've already got, we're left with 90 degrees. I'm then going to take that 90 and divide it into 5 equal piles. So 18, 18, 18, 18, and 18. So that means that the first number of degrees is 3 lots of 18, which is 54, so that's going to go here. So this is 54 degrees. And the second angle is 2 lots of 18, So that is 36 degrees. So that's going here. And the angles all add up to 180, so we know we've done that correctly. Give your answer to correct to three significant figures, work out the length of AB. So we want to work out this side here. Now this is going to be a SOHCAHTOA question. We want a side. We know one other side, and we've got some angles that are involved. Now it doesn't matter whether you pick 54 or 36, but that's going to affect whether you're talking about the opposite or the adjacent or the hypotenuse or things like that. So I'm just going to pick 36. And then I'm going to work out all my sides relative to 36. So if I'm using this 36, I'm ignoring the 54, then this is my opposite, because this side is opposite the 36 degrees. This side is my hypotenuse, because it's the longest side of the right angle triangle, it's over from the right angle. And this side here is my adjacent, it's next to that 36 degrees. If you were ignoring the 36 and using the 54, then 14 would have been your opposite, and this side over here would have been your adjacent. But it's completely up to you which one you pick. It doesn't matter, it won't make a difference to your answer. So now we need to choose, are we going to do SO, CA, or TOA? And because the hypotenuse is involved, because that's what we're working out, and the adjacent is involved, because that's helpful information, I don't know the opposite and I don't want to know the opposite. So this is A and H, so I'm going to use CA. In that CA triangle, cover up the thing you want to know and do the sum that's left behind. So we're covering up the hypotenuse because that's what we're working out, which means we're doing the adjacent, 14, divided by C. Now remember that in the SO triangle, it's sine 36. That's what the S stands for. In the CA triangle, it's cos 36. And in the TOA triangle, it's tan 36. So whatever that angle is you're using, that goes with sine, cos, or tan. So 14 divided by cos 36, typing that in my calculator, and that will give us the answer. 14 divided by, you can either do it as a fraction or you can write divide, it's absolutely fine. Either way, shut the bracket after the angle, and that is 17.30495. So three significant figures, that's going to be 17.3. Question number 27. A is in the shape of a quarter circle of radius 15, and B is in the shape of a circle. The area of A is 9 times the area of B. So this multiplied by 9 makes the area of this shape. Show that the radius of B, the radius goes from the middle to the edge, is 2.5. Okay, so at the minute I don't have any information about this one. I know they've said show that the radius is 2.5, but in a show that question, you don't want to use this answer. You want to get that of your own accord. So we're going to start over here. I know that the area of a circle is pi r squared. So that's how we would work it out. It's also given to you in the formula sheet on the front of the paper. So pi times the radius squared. Now this circle, if it was a whole circle, would look a little bit like that. Drawn better, of course. So the radius would go from the middle to the edge and be 15. So I'm going to do pi times 15 squared. But because I only want a quarter of the circle, I'm going to take that answer and divide it by 4. So pi times 15 squared divided by 4 is going to get you your answer, the area of that shape. And that is 176.7145868. I don't want to round it yet because I'm going to go on and use that. Now that area is given there, but if I want now to get to the area of this circle, I need to divide that by 9 because it said that the quarter circle was 9 times bigger. So if we're going the other way, we're going to divide by 9. That means the area of this circle is 19.63495, but I want to know what the radius is. So I'm now going to say pi r squared needs to equal 19.63. So that's what we now know. Pi r squared equals 19.63495. I'm going to divide both sides by pi, because I'm trying to work out what the radius is here. So divide that by pi. R squared is 6.25, and then square root both sides to get the radius, and square rooting that answer, I get 2.5. So we've shown that we get the same answer, and that's what you want to do on a show that question. You want to do it yourself and show that you get the same answer, And that's it for full marks on that question. That's all we need to do. I've laid that out a bit oddly because I've tried to fit it at the top of the page so you could see the diagrams, but hopefully that makes sense. And we're all done. That's 80 marks. I hope you found that helpful. Let me know in the comments if there's anything you want me to go over or anything you want me to do again. I'll be live on YouTube the night before the exam, 7 till 8 for foundation and 8 till 9 for higher. I hope to see you there.